Hey, Chloe. Let's see. Are you the wait for a few more people to come in? So we are outside today because I want to do something that's a little bit more messy, and I don't feel like doing it in my house. Hey, Grayson. So we're looking at energy. We had talked about energy, doing if I threw a ball kind of thing. I want y'all thinking about while we wait for more people. How would I make this ball bounce higher? What would I have to do to cause it to bounce higher? So that's what I'm want you to think about while we wait in a little bit. Hey, Kinsley. So this is your thinking question while we wait. I want this ball to bounce higher. I want it to have more energy to bounce up. So what would I have to do in order to make this ball have more energy? Hey, Memphis. I said, hey, Chloe. You were the first person. So those are just coming in. We're thinking, how could I make this ball bounce higher? Think of your answer as like use the word energy. We lost a few people. We got about 3 people. I wonder. So we got Chloe, Grayson, Memphis, Kinsley. Okay, so it has something to do with energy. I'm having to do something to this ball in order to bounce really high. Hey, Francis. So we're thinking today's lesson's all about energy. How could I make this ball go higher? Thank you, Grayson. I appreciate it. So how could I want to bounce it, but I want it to bounce as high as it can go. So we need less energy. Some people are saying more force, less energy. So less energy would be where if I just did this. So I'm going to swing you around. Less energy would be this. So I'm not going to do anything with my hand. I'm not going to do as much work. I'm just going to let it go. And it barely reached up. It barely popped up, barely bounced up. So what if I put more work into pushing the ball? If I put more work, that means that my hand is having more energy put into this ball, transferring it into this ball. Okay, so let's see. So I'm going to put more energy. I'm going to, it bounced higher. Okay, so back when we talked about energy, we said that the more energy you transfer into something, the more energy it's going to put out. Okay, so what I want you to do is take that concept and think about some real life examples like a car. If I press the gas pedal and put more energy into the car, more energy is going to come out, just like it's going to make it go faster. Okay. So, hey, Dejan. So we're talking about how could I make something have more energy being put out? And we talked about this ball. And so if I took this ball and I only let it go, if I just let it go, it's not going to bounce as high. But if I push down and I transfer more energy from my hand to the ball, the higher it's going to bounce. So more energy being put into this ball, the more energy this ball is going to put out. So we talked about last time friction. Let's see, gravity. Yes, gravity does have energy It's a force of energy. Chloe said because friction can hold a lot of energy from the ball. Friction, not really friction. Friction has something to do with how it could push up against it to slow it down. Okay, like brakes on the car or the grass, that kind of thing. All right. Oh, I understand what you're saying, Chloe. So you got to put more force and on a place that doesn't have a lot of friction. Okay, I understand. So think about that concept of putting more energy in for more energy to go out. So we talked about in class that if we see it being done, that energy being done, it's called kinetic energy. But if I do this right now, it's not being done yet. That bounce hasn't happened yet, but it could possibly do that. So I wonder what that's called. Who remembers what that's called? The ball right now could possibly give energy. Who remembers what that's called? Kinetic was it actually bouncing. Right now it's not actually bouncing, but it could possibly. Yes, Dejan, it's potential energy. Good job. It potentially could have energy. Just like I told y'all in class that if I tell your parents that you have a lot of potential, you haven't done the work yet, but I know it's in you to do great work, awesome work. You have great potential. Okay. Yes. Good, Kinsley and Chloe and Francis. Hey, Raquel, we're talking about energy right now. We're talking about if I put a lot of energy into this ball by pushing it with my hand, more energy is going to make this ball bounce up. So, and we also talked about how if it actually is doing the bouncing, it's called kinetic. Right now, it's not doing it, but it could possibly do it. So we call that potential energy. Now it's easy to see with the ball energy. It's easy. We know that this could, because we see it move. But right now, okay, in these little tissue is baking soda. I just pre-did it. So there's baking soda in here. And we use baking soda a lot with baking, like doing cookies and stuff like that. Does this have energy? Does baking soda have energy? What's y'all's thoughts? Think about while I get some that flew away. Okay, I'm back. Oh, some people are saying yes. There is energy in this baking soda. There is energy, and we're going to prove it. Right now, it's hard to see that energy, just like if I just hold the ball. Okay, so Dejan, you only need to say no one time. I see it. Okay, hopefully you're not typing it 10 times. Okay, so this ball, just looking at it, not doing anything, there is energy in this ball. It could possibly do it, has potential energy. This baking soda that's in here could possibly do some work, could change something. It has potential energy. Now, it has what we call chemical energy. It could possibly change something, react to something, and make it a completely new substance. Okay? So we're going to show that. Now, don't forget that when we are doing energy, the more energy I put in, the more energy that's going to be put out. All right. So we're going to make a chemical reaction. So I have 1 teaspoon of baking soda, and I have some vinegar here. And I want to put a 1/2 cup of vinegar in my bag, along with a 1/4 cup of warm water. So in goes my warm water. my vinegar. Now we're going to call this an acid. Okay. This is called an acid. Yes, Grayson, your mom showed me it looked pretty good. Okay, so this is an acid. We're going to do a 1/2 cup of vinegar. So I'm about to spill this water. So I'm going to put the water right here. So I only have a 1/4 cup. So I'm going to do 2 of these 1/4 cups to make 2/4, which can be equivalent to 1/2. Using those unit fractions and equivalent fractions helps us, even in science. All right. So I have my solution here. All right. Yes, Chloe, it is a lot like Mentos and Coke. So what's happening is right now I have an acid and it's going to react to my base. This base, right now, these two things both have energy. We're only doing 1 teaspoon of that energy. And we're going to see what happens in the bag. Okay. So I'm going to close it just a little bit. Make a little opening. Let's see if I can do this. Close it real fast. All right, so let's watch. I'm going to kind of shake it. Now, I see some bubbles. I don't know if y'all can see that. There's some bubbles. Now, I did 1 teaspoon of baking soda. Not a whole lot. And we got some bubbles going. So right now, that acid and base is reacting. The energy in the acid and the base, the vinegar and the baking soda, is reacting together to make a new substance called, yes, it did go as planned, Kinsley. So it's making a new substance called CO2, carbon dioxide. It's what we breathe out. It looks totally different. Now, you can't really feel it, but it did get a little bit more, it's expanded. I did put the tissue in. Now, so it's a little bit fuller. It released a little bit of gas. So a little bit of that baking soda went in and a little bit of gas got released. So even in a chemical reaction, chemical energy, we have a little bit of energy coming in, okay? And if we were in the classroom, you could all feel how it's fuller. There's some, it's not as flat as it was. It expanded a little bit because that gas, that CO2 got released. Okay, so there's a change here. That means energy was being released. All right, so let's do another one. So just like the ball, more energy is going to go in. So I wonder what's going to happen with the out. Okay, so think about it. More energy is going to go in. I'm going to do more baking soda in my solution. And I want you to think what's going to happen at the end. Is it going to be the same reaction, a different, or less, or different more or less? Okay, so let's see. I'm going to do the same vinegar. I'll do warm water first. All right. So 1/4 cup of warm water, 1/2 cup of vinegar, okay. I got my solution here. I'm going to do it just a little bit. We're going to see if if it changes. Now I know that it changes. I know that if I put more energy in, more energy will come out, and it will look like as if the bag expands more CO2 comes in, okay? Now this is more baking soda. So let's see if I can get this in here. All right, so I'm gonna shake it around a little bit. Get that baking soda reacting. With the vinegar. Now there's more bubbles. So I know that there's more because of the more bubbles. More CO2 is being released. It's not exactly getting more. Let's put the rest of this vinegar in. Let's see. Let's see here. There's bubbles happening. We're going to check on it in just a little bit. We'll check on both of these in just a little bit. This was the one with with less. This was only 1 teaspoon. This was 3 teaspoons. So even though it's not exploding yet, right now you can see that we only put 1 teaspoon in here. So less energy went in. And then this one. So less carbon dioxide is being made than this one. So same thing with the ball. Where'd my ball go? All right. More energy that is put in, more energy is put out, is released. More energy less energy that's put in, less energy is put out. Okay. So yeah, the new one, this one's kind of cloudy now. It's starting to kind of dissolve. It's not the fantastic show that I was hoping for. Maybe I'll play around with it a little bit more. And after spring break, see if we can get it to explode. Or y'all can play around with vinegar with your parents' permission, vinegar and baking soda. Excuse me. And see if you can make a bag explode. Play around, see which one did you how could you make a sandwich bag explode? Mine didn't work very well, so I'm going to have to go back into the drawing board. So I did 1/4 cup of water, 1/2 cup of vinegar, and either 1 teaspoon of baking soda or 3 teaspoons of baking soda. You can tell that there is a difference. Especially with the bubbles, you could see that there is more gas being released in this one than this one, because we put more energy in here. Now, when I did the 3 in, that means that potential energy being put in than the 1 teaspoon. Okay, so I don't know. I think if y'all can't see this, hopefully you can. I just had a little thing pop up saying it's unstable. So the internet's unstable. So hopefully y'all are getting this. The new one has no air in the bag. So this one, Memphis, that one has no air in the bag. There's air. We put there's some gas in it. Okay, you see the bubbles happening? All right. So vinegar, I put 1/2 cup in both of them. Okay. So you can play around with how much vinegar you put in, how much baking soda you put in. You can do it with, if you have Mentos and Coke, you can figure it out. And if y'all figure out how to make a sandwich bag explode, well, let us know, okay? And maybe after we come back from spring break and we do a new video, we can talk about it and you can share it with us. I don't see, that's the problem, Grayson. I don't have as much baking soda at home. So I got to get more. Okay? It's kind of, we got to get creative now that we're not in the classroom. So y'all were supposed to, this week you're looking at energy on Mystery Science, and I think I did renewable energy. Not really, if that's the lesson I gave. So I want to urge you to really look at that video, try it at home, try the activity at home. It's just paper and pencil kind of activity. So does anybody have any questions? It's kind of a short science. And if you do it at home, like I said, send me a picture of it. Send me what happened. And even if it didn't work, tell me what you did so that other people can learn from it. No, I'm not doing a house tour. It's not clean enough. All right. This is my backyard. It goes into the woods. And I can show you the things we've been growing. So when we eat something, and it has some seeds, we try to see if we can get it to grow. So we had some beans. Let's see if I can have it. We had some beans and we got them to grow. And let's see, that's some more beans. And let me see what else we got going on. Put some beans. We're trying to see what they like better inside the yard or in our little raised garden. Or I'm going to show you, I'll be right back. I'm going to go get the other things that we're starting to grow. It's all right, but they saw it expand farther. All right, guys. So, this was a single tomato seed from a cherry tomato. And it actually started sprouting, which was pretty cool. So this was a little tomato that we got. You got some candy from your church in the mail. Pretty cool. That's a good church, Dejan. Enjoy that candy. So this right here, hey Brennan. So this is a tomato seed that we saved from one of our salads. And we're gonna see, so far it's looking pretty good. And then this right here was celery that from Walmart, and we cut off the celery, the part that we don't really use. We usually throw it away or something like that. And I put it in a jar of water, and look what's sprouting. The middle part is sprouting a whole new celery plant, which is pretty cool. Okay, so we're gonna see if that, once it grows about 4 more inches, we're gonna plant it in the garden. So that would be kind of cool if it works out. So we got beans, we have tomatoes, and we have celery right now. We planted a sweet potato that was kind of getting a little, where not the best to eat, and so we planted that. We're gonna see if it sprouts through the eyes. And then we have some green onions that we found in the fridge that needed to be either thrown away or done something with. So we planted those. So we're gonna see if those work out. Your mom does it too? Awesome. So hopefully after spring break, maybe we'll see some more progress with our plants, and maybe y'all can come up with some ideas to explode this bag. All right. So next week, we will not have any videos because it is technically spring break. The next video we'll do will be not this Monday, but the next Monday. So that would be April 20th. And I'll send a reminder to your parents as well. All right. Miss Lewis is at her house, Chloe. All right. So that's all that I have today. Hopefully y'all are doing your math lessons. I saw some people doing their already did the decimal hunt. Chloe and Dejan, I saw yours. So I want, if you haven't done the decimal hunt, go try it. Look at my comments on some of what people have done so far. And hopefully we can kind of review those decimals a little bit more. On Freckle Math, you should be working through your decimals as well. And Dejan, I put another comment on what you fixed one, but there's some others. Dejan, has nothing to do with what we were doing. Okay. All right. So any other questions? I'll be checking your math and science this week. Please log on daily to your Google Classroom if you can, so that you can see the comments that I'm giving you. Oh, that's going to come in handy, Grayson. An art set will actually kind of beat the boredom, wouldn't it? All right. All right. So, guys, it's time for me to turn it off. And I will see y'all next month, not this Monday, but the next Monday, April 20th. All right. See you later, guys. Oh, Chloe, I don't know when Miss Lewis is going to make a video. All right. Bye.